Two and a Half Admins, episode 91. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, your customary blog post plug, Alan, is Beehive, the BSD hypervisor.
Yeah, in a couple of weeks in a future episode, we're going to be reviewing Jim's showdown of Beehive versus KVM versus Proxmox, was it?
Yeah, I'm not promising Proxmox, but that is absolutely the plan. I've got a machine that a client ordered and just never picked up. A pretty nice dual Xeon rig. It's not a spring chicken; it's a refurbished box, but dual Xeon E5s, relatively recent, from right before the shift to the Xeon Silver and Gold and all that nonsense. Plenty of RAM, some nice enterprise solid state drives in there. It's already fully set up as a Sanoid server, so the first step is just going to be to get a full set of benchmark runs inside a guest. And I think I've been kind of waffling about this, but I think I'm going to use a Windows guest because I feel like that's everybody's biggest problem. I don't feel like people usually have a problem with Linux or BSD guests on a Linux or BSD system. So I'm going to do a Windows guest, and we'll do storage and CPU benchmarking inside the guest. First on vanilla Ubuntu, which happens to be one of my Sanoid servers, and ideally then Proxmox, and culminating in Beehive. But we'll definitely do KVM versus Beehive no matter what. The main reason I wanted to include Proxmox is because I've encountered a lot of people having very anomalous ZFS performance issues with Proxmox that I have not seen anywhere else, and I haven't directly investigated it. I've just kind of drawn a big red line around it by installing Ubuntu on the same hardware and not having the problem, being like, well, there you go. All right, I'm out. Because it's just friends. I wasn't getting paid to analyze it or anything. Enough people have asked about that. I feel bad about just passing down anecdotes that are negative about a very popular system. So I thought, well, let's take a proper look at it this time. I think that'll be of a lot of interest to a lot of folks.
But in order to be able to understand that, if you're not familiar with Beehive, check out our article and get up to speed on what Beehive is, where it came from, and how it's a bit different than things like KVM.
And as for that 2 weeks, I'd take that like Tom Hanks should have taken the 2 weeks in the money pit from the construction company. It'll be at some point soon, let's say.
I think Joe just gave me an excuse to drag my feet. Sweet.
Let's do some feedback then. Georgie said, recently you recommended using rsync to mirror Ubuntu. So far, so good. But then you said you can select what to mirror, and that's not true. The dev files for all distributions are under a single pool directory, so even if you wanted to only mirror the latest LTS distro, you have to mirror everything in the pool, which is the one taking all the space anyway. You could pass the release and content files, but then you end up recreating apt mirror, essentially. In fact, if you have some recommendations on how to selectively mirror Debian-based distros, I would love to hear it on the show. Personally, I use apt mirror, and you're right that it is ugly, but it does the job.
Georgie is correct. I misspoke when I said that you could pick which versions of Ubuntu you wanted to mirror. What you can pick is the architecture. You don't have to mirror the ARM architecture if you don't have any ARM devices. I misspoke, though. You're absolutely correct. If you mirror the Ubuntu distributions with rsync, you're going to get all the versions that are live at Canonical.
All the currently supported ones.
I would go a little further than currently supported because they tend to still have stuff up there, older stuff, for longer than it's really truly supported. So let's just say as long as they maintain that releases packages online, you're going to be mirroring those.
But that's a limitation of how Ubuntu lays out their mirrors, not of rsync itself. They could have separate directories or whatever for each different version instead of just having a directory b/bash that has every version of bash that they offer in it.
Yeah, correct.
Right. So you're going to have a little bit more disk space and a little bit more time or bandwidth than we thought.
Right. Well, I assume part of that is because Ubuntu didn't want a bunch of mirrors that only contain part of it or something. Or they might actually have different sets of directories. Like the fact that that's called pool suggests that there might actually be a directory somewhere that has specific versions and then symlinks or hard links into the pool thing where they have every version canonically.
Now, I will say I've got a local mirror here at my house, and my mirror currently is 1.77 terabytes.
Oh, so that's not that much then.
No, it's really not. It's really not.
And, depending on your infrastructure, you might have more than one version of Ubuntu to try to support.
Exactly. And, it's kind of nice doing just when I was doing apt mirror, I did try to get picky about which versions I did or didn't mirror locally, but then you kind of get caught off guard, right? Like, oh, you're not bothering to mirror Jammy yet because Jammy is still in beta, but then all of a sudden, well, April of 2022 rolled around and now you want it and you never had stopped excluding it from your app mirror, so you don't have it and it's going to be a day or two before you finish downloading it, yada, yada, yada. Whereas if you're just rsync mirroring the whole thing, well, you've got what you need when you're ready for it. And now one thing you can do if you want to cut down on the size of your local mirror, if you know, for example, I don't need anything from the multiverse repository, you can filter that out. You can decide what you want out of main multiverse, restricted, and universe. If that's something that's useful to you, you can cut out a lot of stuff excluding multiverse. Ubuntu, by default, unless you've gone and specifically enabled it, multiverse isn't actually enabled in apt anyway. So for a lot of people, that would be completely permissible.
Well, thanks for the correction anyway, Georgie. Okay, Amoneth writes, in episode 84, Jim recommended Bind over Power DNS for self-hosting authoritative DNS. Or is it Deenis?
It is not Deenis.
I was wondering if he would mind elaborating on why. I've been using PDNS.
You mean PDNS?
No, I don't mean PDNS.
or would that be Pudness? Assuming this actually makes it to air, for those of you who aren't into the joke, a prospective client today repeatedly pronounced DNS Deenis in an interview, and it took everything I had to keep a straight face. Honestly, I believe he thought he was nerd sniping me and that I didn't know how to properly pronounce Deenis.
Anyway, I've been using PDNS with one master and two super slaves for exactly the reasons mentioned in the episode for almost a year, and it's been a wonderful experience. In what ways do Bind and PDNS differ that make Jim recommend the former over the latter?
The big ways that they differ is just that the internet itself, like the actual big kid internet, runs on Bind. The root DNS servers for the actual whole freaking internet run Bind.
For .com, it's exactly half, but yes.
Fair enough. So it just basically boils down to if I've got to learn one implementation of an application that services a particular protocol that's critically important, I would prefer to learn the one that the big kids use. I have never found that Power DNS, or there are several other DNS providers that aim to be smaller and lighter weight or whatever. I never found them particularly more intuitive. I didn't see a good reason to try to dig into them when I had already learned Bind. I also have never found Bind difficult. The closest thing to difficult about Bind is learning how a zone file is constructed. And if your DNS server is a proper DNS server, it is also going to require properly constructed zone files. So you're going to have to learn that part anyway. And if you don't learn that part, if your choice of DNS server uses some custom, easier to read, whatever, blah, 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 it has diverged wildly from the actual core infrastructure the internet runs on. And again, my personal interest is if I'm going to learn a thing, I'm going to learn the real thing, not the Tinker Toy version.
Yeah, in this case, I would say if you're familiar with something and it works for you, go ahead. But if you're new and you don't know what to do, we're going to recommend Bind over something else.
Absolutely. I agree with Alan there 100%. Nobody who's using Power DNS or some other resolver right now, there's another lightweight one that's everywhere. I can't remember it off the top of my head. But whatever, if you're using one of those and you're comfortable with it and it's meeting your needs and it's reliable, that's fine. You should not feel like you have to change or you're being belittled or your program is not good. That's not the point. My point is if you don't know anything yet and you have to learn a thing, I would recommend you learn Bind because it's not that hard. And it's a core building block of the internet.
Yeah. So no reason to stop using Power DNS, but if you haven't started yet, then Bind is probably what you should start with.
DNS mask. That was the other thing I was trying to think of. A lot of people use DNS mask as a resolver.
Or Unbound.
Yeah.
Okay, Antoine says, in episode 81, Jim said, now if you're talking about an advanced persistent threat that may get their initial toehold with the user and not actually do anything yet, and spend a significant amount of time laterally pivoting and privilege escalating and basically trying to access everything before they actually start doing damage, and that's a much more difficult thing to talk about, but very, very few people are actually going to be faced with that kind of APT scenario. The vast majority of those attacks are fully automated. I would love to hear more about this difficult topic. I understand that very few people are facing that scenario, but I'm one of those few people, and I suspect a lot more sysadmins are than we imagine. It's a really hard problem to solve because there's a trade-off between a totally air-gapped system that never gets updates, which is insecure in itself, and never gets backups, which defeats the point of a backup server in the first place, and a normal backup server that's fully connected with everything else and vulnerable to a compromise of a sysadmin workstation or configuration management system. How do you solve this problem in production? I must say I don't know of many places that have really solved this problem in a fundamental way. Google's rumored tape backups come to mind, for example. One approach is to segregate the network into multiple authentication layers, storage, and hosting domains. An off-site backup server, for example, could be hosted at a different hosting provider using a different contact organization with offline access keys and different domain names. It could pull backups from a more regular backup server using, obviously, ZFS snapshots, or another pull synchronization system with regular long-term snapshots to allow for proper auditing in case of a compromise. But a concern I have here with using ZFS as a backup system is what happens when there is a data integrity bug or vulnerability in ZFS. And before you start rolling your eyes, I'm talking about real existing problems here. Recently, FreeBSD released an errata which could cause applications to misbehave on an LSEC call, and more critically, Ubuntu 21.10 shipped with a serious ZFS bug that created corrupt ZFS file systems. And then he links to an article and says that article is interesting because it shows how relying on a single stack for backups can have a fatal flaw. One critical bug or vulnerability and the entire stack comes falling apart. What do you think of the 3-2-1 approach to backups? Would a ZFS backup system be compatible with this?
Okay, so there's a lot here. The first thing I would like to point out is there's no such thing as solving this problem. There is mitigating the problem being described to a sufficient degree for your organization. But basically, you've got to balance the expense and the difficulty of higher security levels versus the real threats that you face. Nothing is ever going to be perfectly secure. In order for something to be perfectly secure, it pretty much has to be perfectly unusable as well. So it's a slider. It's not a push button on or off. So moving on from there, the way that you deal with an APT, it's about detection. It's not really about prevention. Air gapping is not really the answer to dealing with an APT because it may take them longer to get to where they need to go, but air gapping doesn't do anything to tell you, hey, somebody is inside someplace they shouldn't be and poking around. So the key here is mostly going to be monitoring. You want to look for anomalies in, how much load you have and which systems are trying to contact which other systems. The further we get with this, the more expensive it is, the more people that you need to maintain it properly, the more skilled those people need to be. So not everybody can go the entire direction, whether it be because of personal skill or because of budget in the org or whatever. But for example, I mentioned what systems are talking to which systems. One of the ways that you can find an attacker inside your network looking around when they're trying to be very stealthy is you put some honeypots in there. You put a system in there that absolutely nobody and nothing should be touching, but it looks tasty. And so when somebody tries to pivot to that, they succeed and they say, oh, hey, I'm in this system now. That's nice. Let's see where I can go from here. Meanwhile, you've got your alarm bells going off and ding, 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 ding. Somebody just shelled into the honeypot. Oh, crap. Let's figure out how that happened. And now you can chase them down. Similarly, like I said, you can look for like load specs and databases because when usually even APTs, when they go to exfil data, they're not very subtle about it. They will frequently cause database servers to spike to 5-10 times the load they normally would. And even before you've got an APT, you may just know I've got a real performance problem. I need to deal with that.
Yeah, or just suddenly more stuff's being uploaded to the internet than it makes sense. And it's coming from a machine that doesn't make sense.
Yeah, so you may see the load spike in application or database servers. You may see your upload out to the internet in general be a lot larger than it should be. That part, the larger the organization, the more difficult it's going to be to see that, but that's where the network segmentation comes in. So you're not just saying, what does my upload pipe to the internet look like right now? You're saying, okay, why is this one user's workstation in this department uploading this much data to the internet right now? That's not normal, and I should look into that. But again, for all this to work, you have to have that segmentation. Now, we also talked about backups and how do you keep the backups secure? And, do we have problems with ZFS bugs? Again, we're looking at segmentation. We're looking at different policies. So at my larger and more secure organizations, the backup servers are far more secure than the production servers. And that's the way it always should be, because your production server can't be more than a certain amount of secure, because by design, it has to be interacting with humans. And humans are sloppy and gross, and they need complex services and systems, and they do weird things, and it's very hard to filter out the noise from just humans being humans. Whereas your backup infrastructure, very little should be touching that unless there's actually a problem. Your monitoring service will be touching your backup server, and that's about it. Getting root and production should not grant you any leeway to getting into your backups. Now, again, this is going to depend to some degree on how complex your org is, how much time you've got to get dug in, what appetite there is to support you digging in and get everything exactly the way you want it. In a high security enough environment, your very first level of backup, an on-site hot spare, it might not be air-gapped, but it might not be exposing anything to the network. Not listening on any port. You can't shell in. You can't do anything. The only thing that you can do if you want to get access to that thing is go walk your butt physically into a locked room and sit down in front of a keyboard and a monitor and go from there, because it's a pole. So nothing else has to be able to touch it, other than you probably want to poke a pinhole for monitoring and make sure the thing's working, unless you've got so much budget that you can literally just have an employee walk in there and sit in front of it every day and say, yes, I sat in front of it and I checked and everything looks good. Probably don't want to do that. So now we're looking at a server that, there's no SSH exposed. There are no services other than the one monitoring service exposed. It becomes very easy to monitor, very difficult to pivot to. And again, in my larger orgs, fewer people have the passwords to get to that anyway. Whether you can shell into it remotely or not only is the key and the passwords and whatever in production not valid for the backup server, but who actually has those? There are fewer of those people. In one of the larger organizations that I work with, there are 10 or 20 people that have root on various production pieces of infrastructure. There are 2 who have access to the backup server. And frankly, that's one too many, because if you have physical access to the backup server, you can always break in physically by changing the root password on the host operating system and go from there. Now, the next step down, we talk about, potential ZFS bugs. The best example of this is really not ZFS at all. It's Waffle, NetApp's proprietary file system. In the late 2000s, there was a really nasty Waffle corruption bug that would propagate via replication. Now, replication on Waffle works very similarly to how it does on ZFS. And with this Waffle bug, if you replicated from a corrupted Waffle file system to another one, you would corrupt everything on the target as well. Not just the production version of the file system, but all the snapshots going back to day one. That one replication would nuke everything. ZFS has never had a bug that bad so far. I don't think that one is very likely. However, like was mentioned, you can have problems. And one of the best ways to hedge against that, even if you can't afford to have a proper 321 where you're talking about like a different file system, a different medium, on your third of the 321, what you can do is you can alter the frequency with how often you update it. So typically in my topologies, I've got a production, I've got an on-site hot spare, and I've got an off-site DR. Now the replication frequency to on-site hot spare is hourly. To off-site DR, it's daily. So I've got a full day to notice, oh crap, everything, went wheels up on my hot spare infrastructure as well as prod. Stop the offsite replication now. And I've had to do that before. It is a technique that works. The only thing that you have to do is make sure that you are actually detecting and finding those problems more frequently than you're replicating to your third of the 321. And you can extend that. You can have more than that, because my problem is I can't do a proper 321 with the data that I really care about because there's too much of it. I can't afford a traditional rsync style backup. In order to do that, I would have to shut down everything in prod because the storage load would be too high for rsync. I can't run 20 hours out of 24 performing an rsync backup on a snapshot. It doesn't scale. It won't work.
It would only help in some of the situations, not all of them, of having, replicating via ZFS and then rsyncing from that, where you might be able to deal with it a little better and use a snapshot as the source so that you're getting a consistent version, but it might not help there either. And it actually connects, one idea for that is connect back to the conversation we just had about DNS. The root.com DNS zone is run by a company called VeriSign, and they purposely have half the DNS servers running bind and half running, I think, NSD or something from NLNet Labs, one of the other popular DNS servers. So if there's a vulnerability in bind, it can only take out half of their production. But then they split it half the other way, where half the machines run FreeBSD and half of them run Linux. But this way, if there's a vulnerability in any one thing, it can only really take out half of their infrastructure any which way on that grid. But with something like that, just from the examples you pointed out, if you had one of the backups being ZFS on Ubuntu and one of them being ZFS on FreeBSD, they wouldn't have got hit with the same bug at the same time.
Mm-hmm.
You know, it's not quite the same as a different file system, but having any kind of diversity in there can help against not just the threat of a ZFS bug, but an OS bug or a vulnerability or whatever. Because like Jim said back when we were talking about the APT part, it's really defense in depth and, like you said, that trade-off. The more and more secure you make it, the harder it is to use, and that will eventually make people not productive or not happy. And so you can keep locking it down, but eventually it gets so cumbersome to do your work that it just won't make sense. And you got to be careful with that because people are always going to rebound too hard the other way.
Yes. You know, in order to get the proper 3-2-1, for me, it would actually have to be like a 4-3-2-1. I could conceivably set up a second offsite DR that did like an rsync style mirror periodically from the primary offsite DR that gets updated once per day. In practice, that just has not been worth doing for me at any of the places that I've been.
Okay, this episode is sponsored by Linode. Go to linode.com/25A, support the show, and get $100 free credit. From their award-winning support offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. Linode offers great price-to-performance value for all compute instances, as well as block storage, Kubernetes, and more. Linode makes cloud computing fast, simple, and affordable, allowing you to focus on your projects, not your infrastructure. So go to linode.com/25A, create a free account with your Google or GitHub account or your email address, and you'll get $100 in credit and support the show. That's linode.com/25A. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. You can learn more at 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions for Jim and Alan, or your feedback, or anything really, show@2.5admins.com is the email address. Okay, Peter writes, what is the best method to enable an Active Directory-style membership in an open source method, or is it just too hard and complex for home hobbyists? NIS or Open LDAP, or free IPA, or a turnkey solution? My scenario is I have a home lab with lots of servers and services, maybe 10 plus instances, all running Linux and open source solutions like Nextcloud, and I tend to just keep setting up local admin and a local user with the same username and password on each service. Is there a simple solution to allow domain users and computers? I assume you need to add computers to a domain to allow authentication.
So my answer here is going to be actually quite simple. You can just use Samba 4 to create an Active Directory domain controller. You can also use Samba then to join your individual Linux or BSD machines to that domain that you're using Samba itself as the domain controller for. Beyond that, that gets you most of the things that you're used to, assuming you are used to Windows and Active Directory. The big thing being, single sign-on. Once you have joined the machines to the domain and you have created domain accounts, with a domain account, you can shell into any of those machines. You can do the things. You have the privileges that you should, whether it be sudo or whatnot. Now, as to how you get that installed, there are a couple of methods. It's not that hard to just spin up Samba 4 itself directly as an Active Directory controller. You can find a ton of walkthroughs out there. None of them are all that difficult. If that's still a little hinkier than you want to deal with, I would recommend Zigmanaz. Zigmanaz has a built-in Active Directory domain controller feature. It works extremely well, and it is as easy to set up and use as it possibly could be. I mean, you're pretty much just, you give the domain a name, and you set up some accounts, and it's there, and it works, and that's it. Now, I will say you must be certain to back this stuff up properly, because just like with a Windows machine, if you lose the domain, you're going to lose a lot of functionality on every single machine. So be careful about that. Now, the last thing that I'll say about this is if you don't want to go the Samba domain controller route, you also have the option of just not doing a domain at all. Peter said that he's tending, unfortunately, to just use the same username and password for everything on all the machines. You don't need to do that. You can instead build everything in basically webs of trust, where the most trusted machine is either your workstation or, if you want to be a little bit more secure, a jump host. So before you do anything crucial on your network of machines, you first shell into your jump host, and your jump host has the keys necessary to shell you from there into all the rest of the boxes, whether it be as root or whatever. You can take a step further beyond that, and so far what I've described you can do easily manually. You can also take a more Allen-esque approach and install, a management stack, be it Puppet or Salt or Ansible or what have you. Deploy all your machines using that, and you get kind of the built-in management at scale without having to set up all these little individual things that you're looking for, and you never really touch like a directory at all.
Yeah. In the past, I've done the Active Directory thing, although when I did it, it was 15 years ago. So it was Samba 3, and that was doing a Windows NT4 style domain, which was a little more hinky.
It's a lot more hinky, but Samba 4 does a proper AD controller. So far as I can tell, I haven't tried to use it in production. I've tested it pretty thoroughly for doing, like reviews for Ars Technica and what have you. And the Samba 4 AD, you can even integrate it into the actual Windows Active Directory domain. Like you've got one in production that's got a no-kidding Windows Server AD domain controller. You can absolutely join a Samba 4 DC into that domain, and the Windows boxes will recognize it and say, yep, this is one of our DCs. It mirrors the global catalog. It does all the things. And with that said, that's not how I personally would choose to operate in production, but I have deployed that, I have set it up, and I have at least lightly supported it for like a couple of university departments that basically demanded that kind of thing.
Yeah, the one I did was basically for a cyber cafe so that you could have single sign-on across all the machines. So the machines were all Windows, but the server was FreeBSD with Samba on it. And Samba was actually using OpenLDAP in the back end for it. And so if all of your clients are Linux and you don't have any Windows and you just want that style of thing, then you could get away with doing the same thing with just OpenLDAP or NIS.
But you will have to work harder to do it and understand what you're doing a whole lot more. If you just want easy install the thing and go, the absolute easiest is going to be technically either TrueNAS or XigmaNAS. But in my testing of TrueNAS's Samba 4 Active Directory implementation, it frankly sucked rocks. The XigmaNAS stuff just worked. All the operations completed immediately and did what they were supposed to, and you didn't have to hold your hand behind your back and jump 3 times around in a circle or whatever TrueNAS required you to do. And all the operations complete instantly, so quick. My biggest problem with the XigmaNAS setting up it as an Active Directory controller, I assumed that it had broken the first time I did it because it completed literally instantly. And if you're experienced with Windows Active Directory, you know that like joining a domain takes a while, right? Like even on very fast machines, it may sit there and think for 30 seconds before it does much of anything. Whereas the Samba 4 under XigmaNAS, if you tell it it's a domain controller, it's a domain controller. If you tell it to join the domain, it immediately says, yep, join the domain. And you're like, what? That can't be. But no, it really was that quick. It just worked.
Yeah, but no matter which of these solutions you use, basically it will extend what the local users are to include the ones from the directory, whether that's NIS, LDAP, or Samba. And so when you set a sudo rule for the group wheel or whatever group you make up that allows them to do something, any of the user from the domain that's in that group will show up and it'll just work that way.
Yeah, so it works like local users on every machine, but this is not necessarily 100% technically accurate, but effectively the way it works is it replicates the user accounts in from the domain controller as they're needed. So you're not going to see every account that's allowed to log into the box on the box the first time you run it. But if you attempt to shell into the box as an allowed user, it will immediately in the background create that local account for you based on what's in the Active Directory in time for your login to succeed. And from then on, that login is already set up and created on the box. The password authentication happens, via the back end the way that it's supposed to as well. But you should not expect, like if you got 20 users on your domain and you don't have any restrictions about which ones can log into which box, you shouldn't expect to see all 20 users on a box that just joined the domain. you'll see them show up as somebody actually logs in successfully.
Well, I think even if you just use like the ID command to look up the username, it's going to find the record and print out, the person's real name and all that.
Yeah, but that's the LDAP stuff. I'm talking about the local user stuff, like whether you see like home directories and all the other stuff, all that gets created on the fly.
Yeah, and it depends which way you go, whether that will use install certain .bashrc files or whatever, and with Samba you can set it up so that they have a network home directory, so that their home directory is the same across all the machines they log into, or not, depending on how you want to set it up.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send in your questions for Jim and Alan. You can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Alan Jude.
We'll see you next week.